Hello science fans, welcome back to Science Fun with Austin. Today we're answering a question. How do you know if there's been a nuclear disaster around? Just in case you missed this. Maybe you slept through it or something. You may need some sort of device to tell you if the environment around you is radioactive. That's why we've built an ion chamber today. Over here we have 2 transistors, a 9-volt battery, a can, and a multimeter. It bounces around a little bit, but the multimeter you can see is reading about 0.08 to 0.1 volts. Here we have the radioactive thingamajig from a smoke detector. Kids, don't go build nuclear piles from old smoke detectors. We've put that in our can, and you can see we're reading about 0.25 volts now. Take it back out. Let her settle down. And we're back to 0.08. Few pointers when you're setting this up. If you take a look inside the can, you can see that what we have is a wire, which is electrically insulated from the outside of the can. So when we insert a radioactive source, it ionizes the air and allows a little bit of current to flow between the can wall and the wire. But since we're talking a very small current here, you need to have a really good insulated connection at the top. One thing about the ion chamber too, it works with ionizing radiation only. So even if we put a pretty intense bit of visible light in here from our 405 nanometer laser here, you can see we don't get much of a response at all from the multimeter. Even though we're putting in way more energy with the laser than we were from the americium, we aren't generating any ions, so we aren't closing the circuit. And when we put the americium back in, we're back up to about 1/3 of a volt this time. This circuit is fairly simple, and it does enable you to build a radiation detector out of things you probably have laying around your house. But it does have some limitations. It's sensitive to stray electric fields, and it seems to have some temperature stability issues. Sometimes the heat kicking on can change your readings. So, as a challenge to any of you double E's out there, if you can make your better radiation trap, send in your video and we'll put it up.